Hi, everybody. I'm just going to do a little explanation of Lab 9. And so the third part of Lab 9, and what I'm looking at here is the Bode plot for the system when k is equal to 1. And what I want to find is the gain in phase margin. So if I just quickly mark up the screen here, when you want to find gain margin, you find the minus 180 crossover point on the phase, and you go up to the gain. That should be a straight line. You go up to the gain, and you look at how far is the gain below 0 dB, right? So this little amount here is our gain margin. If we're below 0 dB, we're still stable, and that's our gain margin. To find the phase margin, you look at where the gain crosses 0, and you go down to the phase, and the difference between that phase and minus 180, that's, and it should be, you know, visually above minus 180, that is your phase margin. Okay, and sometimes you want to change your gain to get better gain or phase margin, and sometimes you have really good gain and phase margin, so you actually just want to increase your gain to get a better performance response, but then you're looking at you know, how much can you increase that gain before you do get yourself into an unstable position, or a position where you don't have enough margin. So what the third part of Lab 9 is asking you to do is to look at the gain margin and phase margin, and then actually bring the gain down to get better phase margin. So first, let's look at what we actually have here. I'm going to put some cursors on the screen so I can get better values. I have, so there's the minus 180 degree point at 0.63 radians. So I'll go up to the gain plot at 0.63 radians. And I can see I've got about 8.7 dB of gain margin. And I'll look at where the gain plot crosses 0, which is at roughly 0.37 radians, and I'll go down to the gain, or to the phase plot, and we're looking at a value of about minus 162. So at minus 162, the difference between there and minus 180 is only about 18 degrees of phase margin. And our guidelines say that 18 is not enough. We want 40 degrees of phase margin and 6 dB of gain margin. Now we have more than 6 dB of gain margin. So from the gain margin perspective, we're okay, but we want also to have that 40 degrees of phase margin. So let's just write down those values. Lab 9, part 3. We have a gain margin of 0 minus 8.0 minus 8.7 dB, which gives you 8.7 dB. And then we have a phase margin of minus 162 minus 180, which gives us 18 degrees. And so we're saying at least, we want at least 6 dB, so this is good. And here we want at least 40 degrees. So we know that that's not enough, right? I mean, this is the right answer, but this, what we're saying here is that this is not sufficient. We're still stable. We still have gain margin and phase margin. So we're still stable because these numbers have come out positive. And we haven't gone like above 0 dB or dipped below the minus 180 degree point. So we're still stable, but we're not sufficient. So if we go back to our Bode plot and we look at this Bode plot, if we don't have enough gain or phase margin, we have to bring our plot, our gain plot down. And what we're going to do is, let's see if I can just draw this on the screen. What we want to do is, because when we change the gain, the phase plot itself will remain the same, because a change in gain only moves the gain plot up or down. So knowing the phase plot will remain the same, I can go over to this point where the plot is roughly at like minus 140, because that would give me 40 degrees of phase margin. And I can go up to the gain plot and I can look at this distance, how far the gain plot is above 0 dB. And I'm going to say, well, you know what? I really want to lower the gain plot to this point, because if the gain plot crossed the 0 dB axis at that point, I would have the phase margin that I want. So to get some exact numbers for that, I can erase my my drawings here. And let me find this minus 140. So there's minus 140 at 0.2 radians. So I go up to the gain plot at 0.2 radians, and I see that the magnitude is 9.11 dB. Okay, so I know that my gain plot can be lowered by 9 dB. So that would be a gain of minus 9 dB. And that will give me the phase margin that I want. So writing down those numbers, I know that that minus, what was that exact number? Let me go back. Yeah, so minus 9.1 dB is the drop in gain that we want, and we want to, you know, un-dB this and figure out, okay, what is this K that gives us that drop, right? So you have to work that out for Lab 9, and then when you do, and you plot it again, I'll just show you what that looks like here. So I already have a simulation in my block diagram that that is running with the new value of K. So what I did, I just told the Bode plot block here to pull in those other linear analysis points, and then I'm going to run this Bode plot again. So I'm pressing the play button, and now I see both plots. So this top gain plot was my K equal to 1. This bottom one was with my new K, which is a K value less than 0. So it dropped my gain plot, or sorry, with a K value of less than 1. Sorry, let me just say less than 1. So I brought the gain plot down, right? By reducing my K, and that's the value that I'm letting you find. But let's just look at the graphs. So with the new graph, my gain margin is now this much. So I actually have increased gain margin, and that's good. And looking at the zero crossing for the gain, since I brought the plot down, it now crosses zero at a point more to the left, and I go down to the phase plot, and I now have this much phase margin, which is a lot more. And if I clear the drawing here, and I'll put a MATLAB cursor there. So at this point where I cross 0 dB is 0.185. Roughly somewhere around there. It says that my phase is minus 139 degrees, and so my phase margin would be 41 degrees at that point, and that is perfect, right? So you have to figure that out and simulate it and show it for Lab 9.